In this video we will be solving quadratics by completing the square, and we're going to use these perfect square patterns which we worked with when we factored. So the trinomial is in this pattern and its factoring looks like this. And remember that a plus b quantity squared, this right here, this is what it means, a plus b times itself. So we have two matching factors in that case. So for example, let's say we had x plus 5 quantity squared. So that trinomial, if we FOILed it out, would be x squared plus 10x plus 25. That's the way it would look, and it would end up factoring to this right here. So our goal today, we're going to be given a trinomial and we want to rearrange it so that we can end up factoring it with the perfect square pattern. We had two perfect square patterns. If our factor had an addition sign in it, the symbols were plus plus. If we have a subtraction sign in our factor, it was minus plus. So we'll have one of those two patterns when we look at these. So with that said, let's apply this to this first one. So r squared minus 8r minus 20 equals 0. We want to solve this quadratic by completing the square. So our middle term is where you're going to focus. We also want to check first and make sure our leading coefficient is 1. If it's not, we'll handle that in later examples, but in this case it is. So then we look at this middle term. The process is this. You take the coefficient of this middle term, in this case negative 8, divide it by 2. So we're going to take negative 8, we're going to divide it by 2, which is going to give us negative 4. And then we're going to square that, and that's going to give us 16. That number needs to be right there in order for this perfect square pattern to work. It's not there, so we're going to have to rearrange this. So we get r squared, subtract 8r. I'm going to add 20 to both sides. So I'm going to add this 20 here and here. So then leave some space, and we have this. We have an open space right here. That is where we want to insert this number that we calculated. So that's 16. So plus 16 goes right here. That way, this one right here will factor as a perfect square. It's going to factor this way, r minus 4 quantity squared. That equals 20. We added, I forgot to tell you this, we added 16 right here, so we need to add 16 right here. So let's fix that. So 20 plus 16 is 36. So right now we have r minus 4 quantity squared equals 36. Now we solve it. So we did this when we solved using square roots. We need to square root both sides to get rid of the square. When you square root, you have to put in the plus or minus sign. So r subtract 4 equals plus or minus. The square root of 36 is 6. So now we add 4 to both sides, and we get r is plus or minus 6, and then add 4 to that. So 6 plus 4 is 10. That's one solution. And negative 6 plus 4 is negative 2, and that's the other solution. So our two solutions are 10 and negative 2. All right, second example here. We want to solve this quadratic by completing the square. So we have a leading coefficient of 1. That's our first check. Next check, we take this middle coefficient, this value right here. We divide it by 2, and then we need to square it. So I'll do it here. 8 divided by 2 is 4. Square that, 16. So we need a plus 16 right here in this place. So first we're going to add this 9 over here and get it out of the way. That leaves us with n squared plus 8n, leaves some space, equals 9. That's what we have so far. We need to place this 16 right here, so I'm going to add that 16 here. Whatever we do to one side of the equation, we have to do to the other to keep it balanced. So I add 16 to both sides. Again, why 16? Because I want this to be a perfect square pattern, and this number right here, the way we come to that number is take this one, divide it by 2, and then square it, because it's going back to this pattern up here. That's the way the pattern works. Okay, Next step, we have n squared plus 8n plus 16 equals 9 plus 16, 25. The way that we already have this set up as a perfect square. So our factoring looks like this. We take the square root of this one and the square root of this one, put them in parentheses together, and square that whole quantity. That's the pattern. That equals 25. So this right here factored to this. If you FOIL this out, you'll get this. So we're solving here now. So we square root both sides to get rid of that square right there. So we get n plus 4 equals plus or minus 5, because the square root of 25 is 5. Whenever you take the square root of something in your algebraic process, you have to include this plus or minus in that step. So we need to subtract 4 from both sides. So we get negative 4 plus or minus 5. So our two solutions come from this plus or minus. So negative 4 plus 5 is a solution, and negative 4 subtract 5 is a solution. So negative 4 plus 5 is 1. Negative 4 minus 5 is, I don't know why I wrote 0. Negative 4 minus 5 is negative 9. So our two answers are our variables n here. So n equals 1, n equals negative 9. All right, last example for this video. We have x squared minus 6x minus 16 equals 0. We want to solve using completing the square. So I look to see if my leading coefficient is 1. It is. So now I look at this middle term, negative 6. In order to make the perfect square pattern work out, I need a number here that is this one divided by 2 and then squared. So I take the middle coefficient, the negative 6, the one with the x term. I divide it by 2. Negative 6 divided by 2 equals negative 3. I then square that. Negative 3 times negative 3 is positive 9. So I need a 9 right here. I don't have a 9, so I'm going to add the 16, move it over to the other side, and leave a space to put that 9 in. So leave a space equals 16. I need this 9 right in this spot, so I'm going to put it there, plus 9. If I add 9 to this side, I have to add 9 to this side to make it all work out. I need to keep the equation balanced. So I now have this, x squared minus 6x plus 9 equals 25. 16 plus 9, 25. Now this is set up to be a perfect square. This work right here ensured that. So I have a minus plus pattern here, so my factor is going to have a subtraction sign in it. The square root of x squared is x. Subtract square root of 9 is 3. Square that whole quantity, equal to the other side. X minus 3 quantity squared is this trinomial right here factored. If you FOILed out x minus 3 times x minus 3, you would get back here. Now, square root both sides. We're solving for x here. Square root both sides. We get x minus 3 equals plus or minus square root of 25 is 5. Add 3 to both sides. It doesn't matter if I put the plus 3 in front or the back. Doesn't matter. So I have this, x equals plus or minus 5. Add 3 to that. So 5 plus 3 is 8. That's the positive 5 plus 3. So that's a solution. Negative 5 plus 3 is negative 2. So 8 and negative 2 are the solutions. That's where this parabola crosses the x-axis. Alright, I'm going to work one more example for the video and write down the steps that we are using here, and maybe that will help. So, step 1 when we look at these is we look at the leading coefficient. I'm going to abbreviate here, leading coefficient, and make sure it's 1. You can complete the square and solve these if the leading coefficient is other than 1, but we will not be doing any of those in this video. So we are looking to make sure that it is 1. So it is. So then step 2, we take the middle coefficient, this one right here, the one with the first power variable here. I'm going to abbreviate that as MC, middle coefficient. We divided that by 2, and then we squared it. So for us, that would be the middle coefficient is 2, divide it by 2, that gives us 1, square it, 1 squared is 1. Okay, so we then, step 3, put that number that we just found, put that number in the last place. So for us, that would mean this, k squared plus 2k plus 1, and then we have the minus 3 equals 0. We don't want the minus 3 there. We need a positive 1 here to make our perfect square pattern work out. So I need to move this 3 over. Okay, I'm not writing down any more steps from there. The first 3 are the ones that seem to confuse most students. So then we have k squared plus 2k plus 1 equals positive 3. Now we're going to factor this using the perfect square pattern. The way we have already set it up to be the perfect square pattern. So all we have to do now is take the square root of this one, k, write it here. Take the square root of this one, square root of 1 is 1, write it here. If this pattern right here is plus plus, we use a plus here. Quantity squared, and now that equals 3. So I added a 1 on this side. I needed to add a 1 on this side. So I add the 1 here. 3 plus 1 is going to be 4. So running out of room here. K plus 1, quantity squared equals 4. Now we just solve for k, so we square root both sides. K plus 1 equals plus or minus 2. Solving for k here, so we need to subtract the 1 from both sides, so we get k equals negative 1 plus or minus 2. So our two solutions are k equals negative 1 plus 2 is 1, and k equals negative 1 subtract 2 is negative 3. So solutions are k equals negative 3, k equals 1. So recap. Make sure that you check that the leading coefficient is equal to 1. Then you take that middle coefficient, the one right here, divide it by 2 and then square it, and that'll give you the number that you need right here. You'll move the other number that's already there to the other side, and then use your perfect square pattern that you have created through doing what you did in step 2, factor it, and then solve for your variable from there, taking the square root of both sides. That is it for this video.